He's going to say that a demolition cannot be done overnight. That their engineer says it will take weeks to demolition a building. Look, they're not going to go in there and remove asbestos, etc. It's too hazardous a building. So this will not take weeks to demolition. If they want to do it where they're worried about the surrounding buildings, you bring in some cranes. These long-ass mats hang from the cranes, and they act as shield protection. They're made of like a rubber, and you lift them up around the building, surrounding the building on two sides or three sides, the street side too. Surround the building with the large mats. You bring in an excavator that actually reaches that tall. It's only 12 stories. Reaches that tall, but we already know this building loves pancaking, so they could actually probably put some blast caps on the bottom right of the corner structure as closer to the building that collapsed, and that would create a cantilever of the rest of the structure there, which would then make the building rotate inwards. That would get it away from that field to the building to the left. It would rotate inwards, and then go ahead and use your machinery and finish off the rest of the structure. There is the shear wall, that great shear wall, there's a solid wall going all the way up. It's the stairwell. Anyway, look, this is just a matter of an excavator. You don't have to use any explosives. An excavator can reach that tall and start pulling apart that top floor, and I'll bet you'll get pancaking. Now, would the excavator be in the way? It's you often take a floor. Would the excavator be in the way? Looking at the way this thing pancakes, you can try to figure out one corner here to the next, and it seems like it almost stays within its footprint when it starts to pancake. That it doesn't have enough tension on the back side to allow the building to roll over. So let's look at that real quickly. So I was going to get to this one, trying to show you something, but building rollovers. How about rollover? Let's try that. Come on, Google, fix it. There we go. So you have to have a lot of reinforcement in the steel to get a building to roll over. Let's see images. And this building's lacking that reinforcement. Yeah. So these are car rollovers. All right, going back to looks like this one. So you got to have a lot of tension in that interlocking and tension. This one, there's nothing back there really engaging it. So it's already shown a history that it just will tilt maybe 15 degrees and then collapse straight down. It appears that nothing's close enough, and besides, you just fix the pool. If you damage somebody's pool next to it, when you bring this down, you damage their pool and you repair it. But I don't think that's going to happen. It's not going to come out of the footprint. It's not going to reverse and go the other way. It just doesn't. It has about a 15 degree roughly. That before it just can't hold the stresses in the. I really have to show that to you in a model, but the stresses in it can't take the. Can't stay together. That's why this building's able to roll over all the way there, because all of this this is getting compressed. But all back here, all this interlocking of the floors and the columns, they're all staying together. Whereas this one, when it went to about 15 degrees, it just tore apart and collapsed straight down. That's the difference. So saying it's going to take weeks, their engineer is a mouthpiece. You know, they bring in this engineer that says that the other building within a day or so, what he says, oh, that building's good to go. I'd bring my family into there, if that's the engineer she's referencing. I'd bring my family in there. Well, that's actually, how long would he keep him in there? And maybe he doesn't like his family, far as I know. So that doesn't really count. Well, I wouldn't count that as a reason to do something. You've seen me do some crazy stuff to prove shear plane, and a building is being demoed. I stood inside the building, told the operator, go ahead and take down that section there to show you that it would not fall on top of me. I put my life there to show that in one of the videos. Showing you shear planes exist, that it will not make it to where I was. I would have never felt it anyway. It would have just been crushed. It was a live video where you see me inside the building filming the demolition as it's coming towards me. That's how sure that I was about the shear planes that I described. So that was just for you guys doing it. I don't do that for shits and giggles or for or for adrenaline rush or anything else like that. I did that to prove a point. Not many people, I think, saw that video. Maybe I should have re-edited it and said crazy guy stands in building being demoed, something like that. But that's all it is. So here we are here.
As our top priority, and it is important to stress, as our engineer explained yesterday evening, that a demolition cannot be done overnight. In fact, it takes weeks to demolish a building.
All right, let's stop there. Remember, they got a parking garage over there too, so that's protection. They can cripple that building from the parking garage side and let it rotate over. Come on up, Georgie. My cat wanted to climb up. So I find that, just craziness to say it takes weeks. Who knows? Maybe the hurricane will finish it off, and then we'll see if it still takes weeks to demolition a building. I'm going to do a demo for you guys. Right now, I'm still going crazy trying to find the beam, the transition from that deck. So this thing has beams and it has decks. All right, it's got multiple connections. So it's got Surfside building class. It has multiple connections, beams, and also mostly floors that are sitting on top of beams. That are sitting on top of beams with the cantilevers here. But they have beams here. Like I think there's a beam here. There's a beam quite a few places, and some of the beams, they look like they're calling them beams, look like almost columns, but they have two details in the architectural drawings referencing beam and columns. So these are beams here, and those are your columns, and there's your decking. Remember, your decking stood on top of, and that's just punk shear through the flooring, and that's the way this system pretty much is. It's built upon floors that, I'm going over that there. It's built upon floors that are added on top of floors. So we're at page 29. I'm looking for the structural real quickly to show you again. They're built upon floors, but these columns. Where is this? This is a basement, right? So this is the shear wall I'm talking about. So what I'm driving at basically is you cripple it by taking out this guy. This is a freebie. You'll have an overhang. I don't think the building would fail if this one came out. I think it's existing still, this one here. Let me see. How many in my back? This one might be existing still. And there was a return. Or this one might be existing. You're not going to take, you can take this one out and you probably won't cripple anything besides getting maybe this and this side to fall down. Interesting, though, because of this weak steel engagement, you might get a nice ripple effect down to maybe back here even. But I don't think it's going to go past, the planes won't continue. I don't think it'll continue because on this side, we've got, considering these columns going up through the roof and floors are on top of them, you've got some really, really close column scheduling here. Where are we going? And they're larger in scale. These are larger columns. And if you would see it, the way he works it, it's very interesting. His legend, how he uses it. So this is these are the pressure formed piers. Depth equals 3 foot 6 inches. I think people are confusing that they're going to reach the load bearing capacity at 3 foot 6. I don't think it's not the way that works. Let's see what we got here. These are not the as-builts. This is just, and there's a 1, a change of detail. So you got to get to that pressure, and then they tap out with the whatever it may be. It could be down to what they call the bedrock there. Here's the beam schedule. See the B1, B2, etc. BM. I'm looking for BM A. There are your remarks. You can see the stirrups, how they set it up. So there are beams in this structure. That is, that there are beams, like there's one there. There are beams that cross, like the portal area of the car coming in. There's a beam there. It's not just simply the floor connecting. There are beams also intermix here, and there's a schedule of them there. The B column was removed. I don't know where B is. I would love for B, biasly so, to be at the edge of the building where the deck would have been freestanding. That would be my bias. I would love to find out where B was originally. And then, lo and behold, we have B column here, right? But it's not. This is a row column. Sorry, it's not what that is. It would be bad play. They'd be labeled as B, so no labeling here. All right, so this is another detail you would follow. See, BM41, for example. This is I think this is the roof. It's a mixture of garage and elevator section, right? And so we're at the roof at this point. Let's see, I think he does elevation heights. Yeah, 6 foot 8, 8 foot, machine room roof, right? So at that point, he puts this BM41 on each end, and there's the shape of it. So it's on the roof at that point, and then there's some steel, I think. But the BM41, if you look at it on the beam schedule, BM41 is at 137.10 feet. It's 8 inch by 20. It's the bottom and top reinforcement is as such, so it would be 8 by 20 and BM40. So it's two 6s at the bottom and 2 5s at the top, and then under and then we have EC column. Okay, so that would be left blank, and then we have the stirrups at number 3, which is 3/8 rebar at 10 inches on center, wrapped around whatever he's making there, whatever his tent there. But it's kind of confusing because that looks sort of like a column, and yet here are columns here. So it looks like he made a beam column, if you will, there. That's what it looks like. I don't have the pictures, another profile of it. I mean, I don't right there. So I can imagine it's part of his, it stuck around, whatever it was, it didn't fail. That's part of the thing, I think, the overhangs. And then here's some steel going across, tying it in. But it looks this direction and that direction. And then we have, it looks like the reinforced beam going across here. So they put beams in here. Here's BM39, it's BM39 again, BM38. So there's a BMAA as an alpha that I cannot locate that I want to find. Here's a beam at the bottom floor. That's BM36. So there are beams everywhere. There's portal beams that hold up the structure at the floor level. You saw that in the collapse. And then, but typically the floors look like this: slabs, depression at exterior walls. At exterior walls and interior walls too, they have just wrap around. But they build the 8-inch wall. I talked about this. Then they put the 6-inch pad there. I know we get confusing with a 9-inch pad that you talk about, an 8-inch, a 9-inch, I think. But here's 8-inch, and then here's a 1/2 inch, and then they run block on it again. So not to be confused, there appears to be no beam connecting this column to the next column next to it. That there appears, so from here to here, it's just that flooring. It's supported what appears to be by this column and this column. These are the C columns, which are really 16 by 16s, I believe. And this might be some extra framing details like concrete, block, etc. But down here now, this is starting to look like, but I can't confirm it. This is starting to look like more like a beam. I'm trying to get this right. This looks more like a beam detail, but it could be, lintel here and filled in with block. The problem I have is that the elevation of this inside the floor is 13 feet, and this deck is like 12.9. It's like 13.4 inside and 12.9. So this is lower than inside. So this is where I theorize below here is a significantly large beam. Let's run around the building real quick so I can, how do I do that? Damn it. Maybe I'll go back in time. No. How do I get around in front of the building? Human. Great. I don't know where I wound up. Some park. Well, I'm in the park. Hello, park. All right, so then I go back. And there we go. That's good enough for me right there. Let's turn this direction. So here are these beams here. I do not believe these are floors. I believe these are beams right here. with some cantilever effect and some with the decking and then some details added. So I believe those are the beams, or some beams, and I believe it goes all the way around on that area, but I couldn't find the detail as of yet. Let's turn. We come this direction, and this is where I think beams exist. And then we do a little transition. These are smaller columns, and then they're infilled with the outer edges to make up for the window trim detail. Part of this might be a hallway, but I think that's where you look down the ramp, and that's like 10 foot 10 or something like that, or maybe 10 foot 10's here. I'm kind of confused. Is that 10-10 or is this one? So I theorized that the deck, here's the deck here, here's the first floor that's 13. I can't go any further. So the first floor is up here at 13, and the deck's down at 13.4, I think, and the deck's down at 12.9. So I'm theorizing that they connect into a beam there, that they're not spanning like this there, but they're not spanning without a beam between them, acting as a ledger. It gets worse if it's no beam there. That means it is spanning from column to column. It makes it even more susceptible to that earthquake effect, rattling it from the top to bottom as the deck shears off. So, collapsed decks, and we'll end the video with that one. Collapsed wooden decks. Let's just see what we have on imagery on that. Collapse. I didn't say D, but that works for me. All right, let's just use this one. So this one, you can see the column stayed there. This one collapsed away from there. Now, it did it for free. Apparently, the ledger tore away from the house with taking away some structure. But when that tore away, it would have rattled this a little bit. But it tore away because it's probably just a rim board, and it's got floor joists in there to take care of that. There's a rim board there, I believe. All right, so that one was and it stopped there because the failure was down on that side. Now we have this one, and it looks like the rim board, the collapsed deck is down. No puncture because the column just, well, what the hell? What's this? I don't know. The glass, oh, it's a glass railing, and they have a cabana and things like that out there. And so it tore away from the building there. All right, this one tore away from the building here. And it tore away from the rim board there and collapsed down, and it stayed in one piece. This lumber did, along with the ledger board. So it appears that the ledger board, the fasteners sheared away. $1 million is another version of it. So here again, you see the ledger pulling away. There's the ductwork between it. And here's this guy, it's anchored in the concrete, so it was able to hold this up in the air like that. Concrete, on the other hand, because it just punks around there, sheared around it, and when it came down, it still had to release itself from the deck, from the existing building, and that rattled the walls. This framing is took it. Now here's one. Here's one again. The whole porch, it looks like, and a deck came off. But we don't have that, you get wooden framing redundancy on that structure and the deck adding secondarily to it. This deck probably had rebar tied into it. Oh, let's try that. Let me just try collapsed concrete deck. So I could find it under punk shear, but let's try collapsed concrete decks. That's not concrete. That's why we were building it, so that we're going to discount that. No support out here. Looks like maybe it was, maybe not. Collapsed concrete deck. Okay, there is that rip out that I just talked to you guys about, where it just rips down. There's the rebar reinforcement, and those lines. But you can see it stopped, hit the ground. It had no more energy to keep pulling and ripping it down because this wasn't strong enough to keep ripping it out. So there's a rebar doing that, and it collapses over here on the right, obviously. And that's rebar. And what you should observe is that they have this, I don't know what this one token piece of a metal tie across there, but there are no other ties there. There's no cross reinforcement there. So where else we got here? There's a rip-off. There's another one. Yep, there's all the people partying on deck. So they could lean forward, pull it away from the structure at this point. There's it just flapped over. Hey, all right, thank you. That's one's for me. Thank you. Oh, I thought you would get. I pre-thanked you. I pre-thanked you. So oh, sorry guys, I didn't mean to do that. Let's get rid of that. Let's see if it backs me out. I want to get you something else now. Oh, that's what I want to get you. Let me see if it corrects my spelling. That's what I like about Google. I can just sort of just do that and just let it correct it. So images, and so this is what a typical column would look like. Remember, the reinforcement just pushes it out to the outside edge, and then hopefully the steel from here to here will allow it so it can't puncture because it's picked up by the next column. In this case, this was not picked up by the next column. And this, you can see the imbalance of this also. On this side, it's not as it's smooth, just dropped right down there. We already went over this, already talked about this. This one didn't quite puncture, it's holding it up on an angle, but here, clean through, not clean, it's puncture with the load bearing. Here it is here, puncture. Oh, okay. And that is the reinforcement up top there, but it just kicked it to the outside is all it did. It didn't have enough steel integral from here to the next one to allow it to keep the stresses in the column, on top of the columns, rather, on top of the columns, because it's integral on top, not so much on the side of it. Let's see. Same thing there, but what we have here is a deck below that's able to take the load, including this one that's tied in there, probably that rotated, was able to take the load. They probably pulled since it's under construction, they probably pulled the supports out too soon. Nah, I'll take the other one, thanks. Here's the one I showed you in the swimming pool. Maybe they loaded the pool, I don't know. And then this fell through again. The reinforcement wasn't enough to go across. In this old structure of 1976 building code, this worked. This is what it looks like. It is stripped down the side of it. So this is basically what we see in our failure, stripped down the side of it. This is also new construction going on. So it didn't develop enough, or they didn't develop the steel enough into the concrete and into the deck to take the loads and allow it to cure cure enough. This is an example of puncture rotating in and out. There's a elevated deck. As you can see, most puncture takes place on concrete and not the wooden decks. They get some rotations and all that on wooden decks. This is the one I showed you where they pull down on it as the bolts. They pull down and test it for puncture and see how it would happen, how it would react. And they loaded it so they know how much load it would take before you get the puncturing. Notice the 45s, that's the dead load forces. As you find this in a lot of old structures in Philadelphia. And you can see the double reinforcement. Here's one cone, if you will, and then here's another mat out here. And then, of course, that mat would extend out further. And ideally, they both interlock each other. And they'll interlock each other that direction. And so the loading on there, staying within the loading capacity that you want, will never be able to cause it to push around, puncture through it. So grab a pencil, grab a piece of paper, put the paper taut over the pencil, push down, and you have your puncture. At some point, the paper is going to be able to resist puncturing, and you're going to then load it so much that you're going to then puncture through the paper. Oh, this is an interesting setup for puncture resistance. It says innovative puncture reinforcement. That's interesting. Let me just look at this for a second. So imagine concrete freezing us all in place, so they have to react together. There's the elevation. It's interlocking, connecting by concrete here. so we don't look like welded. I have to play with this one for a while. I'm simply into the mind of that it should just make it from one column to the next. That's it. Just one column to the next. Don't just try to make a zone here and wish for the best, saying, okay, this will make it that span. You know, make sure that the loading will make it to that next span, that they interlock from one span to the next. With that said, steel. I love steel, not reinforced concrete steel, but steel columns. And then put your deck on top of that. Put the metal on there, and then put pans, then put concrete on top of your pans. I'm going to end the video with that. I just want you to understand that now. And the deck ledger issue. So now you see hot wide punks here, and then you understand this deck ledger issue. The ledger issue, I've still yet to. It's like I'm going crazy here, trying to find this interaction of the deck. I want to see the deck on this side, the pool deck, and then a profile like this, and then how it connects to the structure. I want to be patient about it. I'm going through each one of these real slowly, and I know people like Lucy are jumping me around saying, go to page 229 for this and that. And I do that for breaking up the monotony, Lucy. But I need to, you know, my process is slow and methodical going through there. And then right now I'm just working on 107. I'm only up to page 86 of 178 of this document, reading every one, the repairs. And this was done by 2002. There's the engineer, and he submits these to the city. So these are city submittals. And he talks about the repair to the the cantilevers, the concrete surface, for example, right here. This one I didn't read yet. So this would be waterproof of the work with. Oh, wait a minute. I'm just thinking that's waterproof. No, I don't know. It's really hard and absorbs the following. Unit 402, workers have installed anodes at reinforced steel. So the anodes, because the steel is rusted out so much, this is one way to make it sacrificial. So they did a lot of structural repairs here, guys. A lot of structural repairs in 2002 down to the bare steel, and then worked their way out. The company that did it appears to be, oh, let me see, I'll go back. Aqua something. I'll come back to 78. Yeah, I'll leave that alone. It's in the other video. Oh, 87 rather. I have to finish digesting this. They did it in April. You know, they got temperature ranges, everything on here. All right, I'm terminating this video. Still have to work on that. I'm still working on a few things here. Be patient with me with this. You know, I know you guys, a few people are so upset saying, it's not this, it's not that. Relax, I'm not there yet. I'm still putting, I need to prove that anchorage to the building. You understand my best failure, load path failure right now. I've yet to be able to prove it. I need to see the anchors to the building. I need to see that. That's buried on the rubble, incidentally. But I need to see it in the drawings also would be ideal. I cannot find columns for freestanding deck at this point. That pool deck, it does not appear to be freestanding. I see no extra column row connected by the face of that building, and then seeing a step down. In the parking garage, I don't know if you see that or not. You would see two columns, one for the building, and then one for the, at the bottom of the ramp, basically. One for the building and then one for the deck. They would be almost on top of each other. I did not see any doubled up in those videos, which I can't tell anymore whose parking garages I'm looking at anymore. Everybody's putting out different parking garages. I did not see this double column. That would look ugly, incidentally. The double column system or single beefed up column that shared the deck. So like a ledge, like the column is like this wide. And then on this part of the column, they loaded the structure of the building. And on this part of the column, they ledgered the deck on top of it. And if they tied it in rebar, we would still get the same effect of some rocking and tearing at the building, causing that earthquake effect. We have the witnesses saying there's an earthquake effect. This accounts for the earthquake effect. If the deck was just freestanding by itself and it collapsed, why would you get an earthquake effect on the structure where you see in that one room where you see the dust falling and the materials falling around? Ending video. Oh, please give me a thumbs up. Please give me a comment. The trolls, please just go ahead and block yourself. If you feel that way, I'm going to block you. I don't have patience for that. I'm not doing this for free, so I don't care about your comment. I don't need it. Anybody else, you can, of course, give constructive criticism, send me in a different direction. Say, I found your column. Say, aha, how about this? You missed this. I don't mind that. That stuff that you missed, that, like I said, the ledger thing. Or yes, they did cantilever the deck on purpose, and it's not touching the building, and they used a Sikaflex along the edge of the building. So, yes, it could fall free without, theoretically, could fall free. Stuff like that, yes, I love that constructive criticism and direction would help. But just to troll me, you're just getting blocked. All right, so yeah, please comment for the algorithm. Thank you. And it can be anything. You can say hello, bad job, night. Well, don't say bad job. You might get blocked because I don't need the negative shit. But you can, say anything. Here's, look at this image, or say what you like to. But anything negative, I'm going to block your ass. Sorry, I don't have time for it. I'm working for free here, so that's the way I feel about it. Take care.